Good afternoon everybody. Today I am going to present a lecture on the topic gauges and gauge design. So, first of all let me tell you what is gauge. In engineering, a gauge is a device which is used to make measurements. There is no significant difference between gauges and measuring instruments, means both they solve the same purpose. They are both used to compare the size and shape of an object against a scale or fixed dimension. But the difference is only that in case of gauge there is no scale given on it. So, this is the only difference between gauge and measuring instrument. A wide variety of tools exist which serve such functions, ranging from simple pieces of material against which sizes can be measured to complex pieces of machinery. Mean to say that we can measure from a simple piece of material to a complex material with the help of the various tools which are available in the industry. Now, gauges, what are gauges? Gauges are the inspection tool of rigid design without a scale. I have already told you there is no scale being mentioned on the gauges, which serves to check the dimensions of manufacturing parts. Means with the help of gauges we check that whether the part is within the specified limit or not with the help of the gauges. Gauges are again of two types, go gauge and no gauge. So, with the help of go gauge or no go gauge we can check whether the part is within the specified limit or not. Now, gauges, they do not indicate the actual value of the inspected part of the component. Gauges do not indicate the actual value. Suppose the spindle that we are going to check with the gauge, it is 29.3 mm. Now, gauge will not give that value or display that value. It is only that we can check whether it is within the limit or not with the help of the go and no go gauges. Now, they are used to determine whether the part is made within the specified limit. I have already told. So, they only tell us whether the part is within the limit or not. Now, various types of gauges include bore gauge. It is a device which is used for measuring the holes. We measure holes with the help of the bore gauge. How much is the bore? We can check the depth of bore. Center gauges, these are again the gauges which are used in the lathe work for checking the angles of the cutting tools and for centering purposes. Next comes the depth gauge. Depth gauge, it is an instrument for measuring the depth of holes, that how deep is the hole, how deep is the slot or recess. We can check with the help of the depth gauge. The most commonly used depth gauges, they are the vernier depth gauge, the rule depth gauge and the micrometer depth gauge. Adjustable gauges such as dial indicator or dial gauge, it is an instrument which is used to accurately measure the small linear distances which are small and linear, which that we measure with the help of the dial indicator. Feeler gauge. Now, feeler gauge, it is a simple tool used to measure the gap widths between the various gaps. The gap widths we can measure with the help of the feeler gauge. Next comes the vernier height gauge for measuring the height, as is specified from the name. We measure the height of the object with the help of the vernier height gauge. It is used for layout work for machining operations or to check the dimensions of the surface. That how we can check the dimensions of the surface also with the help of this vernier height gauge. Next comes the internal groove gauge. The internal groove gauge is very useful for measuring the depth of an O-ring groove. Means for measuring the depth of the groove we use the internal groove gauge. Surface gauge. A surface gauge is used to measure the parallelism of the surface, that whether the two surfaces they are parallel or not. It is used in the layout when we are making a layout of the machinery or the plant, we use this surface gauge, and for alignment, whether the work is aligned or not, that we also check with the help of this surface gauge. Next comes the radius gauge. As it is clear from the name, we can measure the inside and both outside radii with the help of this radius gauge. Next, the ring, plug, snap and precision gauge blocks. They are used as standards to determine whether or not one or more dimension is within the specified limit or not. Means we these gauges, ring, plug, snap gauge, these are used as standards to check that whether the object or shaft or hole we are checking is within the specified limit or not. Now these measurements, these are included or engraved in the gauges itself. So these gauges are called as fixed gauges. We call them as fixed gauges. Gauge blocks. What are gauge blocks? Gauge blocks, they are available in sets from 5 to 85 blocks of different dimensions. And by combining these gauge blocks, we can obtain any dimension that we require. So these gauge blocks, they are made from a special alloy steel because they are hardened, ground and then stabilized over a period of time to reduce subsequent waxing. This is done so that wearing of the gauges is less, because naturally if gauges we are using them, there will be wear and tear of these gauges. So to avoid, not we can say avoid, but to lessen these wear and tear, these are hardened and ground, and also alloy steel is being used to reduce this wear and tear. Their shape is rectangular type with mirroring surfaces are on the opposite sides. The mirroring surfaces, again they are lapped and polished so that they sting together, the surfaces, and the distance between them is the measuring dimension. Now this dimension, it may range from 0.010 of an inch up to 20 inches. Now screw pitch gauges, they are used for checking the pitch of the threads like the Whitworth thread, standard threads, national form or metric type. Next comes the classification of plane gauges, how we classify them. Plane gauges, they are used for checking the plane unthreaded holes which are not threaded and shafts. So gauges are classified as according to their type. Number 1 is the standard gauges, which is made an exact copy of the opposite or mating part. Means the part which we are going to check, the gauge is made exactly to that size, exact copy of that part. And second is the limit gauges. These are made to the limits of the dimensions. Standard gauges, let me tell you what are standard gauges. Standard gauges are made to the nominal size of the part to be tested and have the measuring member equal in size to the mean permissible dimension of the part to be checked. Means standard gauges, they are made exactly to the same size of the part that we are going to check. It is an exact copy of the opposite part or mating part. Limit gauges, these are also called as go and no go gauges that I have told you in the starting slides. So these are made to the limit sizes of the work to be measured. Means they tell that whether the workpiece that we are going to check with the gauges is within the specified limit or not. Now one of the sides or ends of the gauge is made to correspond to the maximum and other end to the minimum permissible size. Mean to say that suppose there are two limits, one is the high limit and low limit of the workpiece. So the one side corresponds to maximum or high limit and other sides correspond to the lower limit. Now the function of limit gauges is to determine whether the actual dimensions of the work, they are within or outside the specified limits. Now a limit gauge, it may be either double or progressive type. A double end gauge, it has the go member at one end and no go member at the other end. This is shown in the next slide. So this is go member is on one end and no go member is on another end. So this is the double end limit gauge. Now the go member, it must pass into or over an acceptable piece, but the no go member should not. What is that? A go member in case of plug gauge, it passes into the hole, and a no go member, it should not pass through that hole. Now the progressive gauge, it has no go member next to each other and is applied to a workpiece with one movement. That diagram I have already shown you about the double and limit gauge. So, next comes the according to their purposes, how gauges are classified according to their purposes. First one is the workshop gauge. Now, this is used to check the dimensions along with manufacturing. When the products are being manufactured, it is on that site or on that table, it is being checked by the workshop gauge. Second is the inspection gauge. It is to check the part before final acceptance. Inspection is being done, and if it does not clear that inspection, it is sent back for the or rejected for further action. Next is the purchase inspection gauge. This is done by the factory to check whether the part they are producing is as per their specifications or not. Next is the reference or master gauge. This is master gauge is used to check the dimensions of the gauge itself, because these gauges there can be changes in their dimensions when they are being used again and again. Wear and tear is obviously happening in these gauges. So these are checked by the master gauges, that whether the gauge is as per the specifications or not, according to the form of tested surface. First is the plug gauge for checking the holes. Now, this is the diagram of a plug gauge. With this we check the holes, whether the hole is as per the specified limit or not. So, there are two sides, as I have already told you. One is the go end, other is the no go end. Now, these gauges are used for checking the holes of many different shapes and sizes. Any shape hole can be checked with the plug gauges. These are plug gauges for straight cylindrical holes, tapered, threaded square and splined holes. Figure shows a standard plug gauge and double ended limit plug gauge used to test the limits. Now, at one end, as already shown, it has a plug of minimum limit size, the go end, and the other is the plug of maximum limit size, that is the high limit, and this is the no go end. Now, these both the go and no go sections of the gauge are on the same end of the handle. Means on one hand of the handle it is go, and on other end of the handle it is no go. Now, large holes, they are gauged with annular plug gauges, which are shell constructed for lightweight. Now, this is the diagram showing snap and ring gauges for checking the shafts. Now, plug gauge it is for checking holes, and these snap and ring gauges, they are for checking the shafts. Now, ring gauge, ring gauges, they are used to test external diameters. With the help of ring gauges we test the external diameters of the shafts. They allow shafts to be checked more accurately, since they cover the whole surface of the shaft. Ring gauges, however, they are expensive manufactured tools and therefore find limited use. Ring gauges are the limitation of the ring gauge is that we cannot measure the journals in the middle section of the shaft with the help of the ring gauge. So, then this limitation is being overcome by the snap gauge. These gauges are used for checking the external dimensions. These shafts are mainly checked up by these snap gauges. These may be solid type, progressive or adjustable or double end. Next come the taper gauges. The most satisfactory method of testing a taper is to use the taper gauges. They are also used to gauge the diameter of the taper at some point. They are made both in the plug and ring styles. These taper gauges, they are mostly made in both the plug and ring styles, and in general follow the same standard as per the plug and ring gauges. Now, when checking a taper hole, a taper plug gauge is inserted into the hole and a slight pressure is exerted against it. If it does not rock in the hole, it indicates that taper is correct. Now, the same procedure is followed in case of ring gauge. The taper diameter is tested for the size by noting how far the gauge enters the tapered hole or the spindle enters the gauge. There is a marking being done on the gauge, and where that mark comes against that size, we can measure the taperness of that or diameter of that tapered hole or shaft. Again, to test the correctness of the taper, whether the taper is correct or not, what we do is we mark pencil lines on the gauge equidistant from them, and then the gauge is inserted into the hole and slightly turned. If the lines do not rub off evenly, it means the taper is incorrect, and if the lines rub off evenly, we can say that the taper is correct. Now, next classification is according to their design. They are single limit and double limit gauges, single ended and double ended gauges, fixed and adjustable gauges. This is a diagram showing single ended, double ended, adjustable, fixed. Next come the limit gauges. Limit gauges are made to the limits of the dimensions of the part to be tested. So, there are two limits of dimensions, one is the go limit, other is the no go limit. Now, the go gauge, it should pass through the over the part, while not go gauge should not pass through the part. This is the diagram showing the limit gauges. On left hand side, it is a plug gauge for checking the holes. So, you can see that between the high limit and low limit there is a tolerance. So, the go gauge, it should pass through the low limit, and the not go gauge, it should be in the high limit range. In the on right hand side, the figure shows a snap gauge or ring gauge for checking the diameter of the shaft. In this case, it is reverse of the plug gauge. The go gauge, it should not pass through the limit, and the not go gauge, it should pass through the low limit. Next comes the allocation of tolerance, manufacturing tolerance. It is economically impractical to attempt to make go and not go gauges exactly to the two limits of work tolerance. Limit gauges, they are made 10 times more accurate than the tolerances. Now, this is again diagram showing a hole in case of plug gauge and shaft in case of snap gauge, the work tolerance. This is also explained by the numerically in the next figure. Suppose how we allocate manufacturing tolerance. For example, let the size of the hole to be tested is 25 plus minus 0.02 mm. Okay. Therefore, the high limit will be 25.02 mm, and the low limit of hole, it is 24.98 mm. So, what will be the work tolerance? It will be the difference between the low and the high limit, it is equal to 0.04 mm. Now, what is gauge tolerance? Gauge tolerance, it is 10% of the work tolerance. So, it will become 0.004 mm. So, what will be the dimensions of the go plug gauge that we are going to manufacture? So, it will be 24.98, which is the low limit, plus the gauge tolerance plus 0.004 and minus 0.000, these are the limits. Similarly, dimension of the not go plug gauge, it is the high limit, which is 25.02 mm. So, in this case, the upper limit is plus 000 and the lower limit is minus 0.004. Now, next is the allocation of wear allowance. Wear allowance is very much important in case of gauging, because if we will not consider the wear allowance in this gauging, then the gauges will be more prone to wear and tear, and the life of the gauge will be very less. So, wear allowance, it is 5% of the work tolerance. As in the previous slide, I have told you the work tolerance was 0.004 mm. So, 0.04 mm. So, the wear allowance will be 5% of that 0.04 mm. It becomes 0.002 mm. Now, what will be the nominal size of go plug gauge? It will be 24.98 plus 0.002. It becomes 24.982, and the dimensions will be of the go plug gauge will be 24.982 plus upper limit 0.004 and lower limit is minus 0.000. Similarly, for the dimension of not go plug gauge, it will be 25.02, upper limit is 0.000 and my lower limit is 0.004 mm. I have shown in the diagram that the wear allowance that we are considering, it has to be taken into consideration. Now, to great or lesser extent, we can say that every gauge is the copy of the mating part for which the gauge is designed. Now, for example, we are to make a bush for the shaft. So, in this case, what is the shaft? The shaft is the opposite part. So, the bush is made exactly to the size of the shaft that we are going to mating with, which we are going to mate. Now, this bushing, it is checked by the plug gauge, because the shape of the plug gauge is also similar to the bush. So, which is further the copy of the opposite part, that is shaft. Now, if the gauge is designed as an exact copy of the opposed part, so that we call it as a standard gauge. That I have told you in the earlier slides. I have told you that the standard gauge, it is made an exact copy of the opposite part that we are going to measure. Now, what is the Taylor's principle? According to Taylor, go and no go gauges should be designed to check the maximum and minimum material limits, which are checked as below. Means that with the help of no and no go gauges, we can check the high limit and upper limit of the workpiece. And the difference between the high and upper limit is the work tolerance. I have already told you. Now, what is the go limit? This designation is applied to that limit of the two limits of size which correspond to the maximum material limit consideration, that is upper limit of the shaft in case of plug gauge and lower limit of the hole, upper limit of the shaft in case of ring gauge and lower limit of the hole in case of plug gauge. Next comes the no go limit. Now, this designation is applied to that limit of the two limits which correspond to the minimum material consideration, that is the lower limit of a shaft and upper limit of a hole. Now, the difference between two is that the no gauge, it should check only one part or feature of the component at a time. Means for separate dimension checking, we need a separate no go gauge, but in case of go gauge, it is written the form of go gauge should be such that it can check one feature of the component in one pass. Meaning in the second pass, it can check the second feature of the component. This is a diagram showing the plug gauge and for checking the holes and snap gauge for checking the shaft diameter. As you can see from the diagram, there is the maximum limit and it is the tolerance zone, and this no go gauge, it should not pass. It should consider the maximum material consideration, and the go gauge, it should consider the minimum limit or minimum material consideration. And in case of snap gauge, it is reverse. The go gauge, it should consider the maximum limit consideration, and no go gauge, it should consider the minimum limit consideration. So, these are opposite to each other, plug gauges and snap gauges in case of go and no go considerations. Now, the go plug gauge, as it is shown in the figure, is the size of the minimum limit of the hole. I have already told you. While the no go plug gauge, it corresponds to the maximum limit. Similarly, the go snap gauge, it is of a size corresponding to the maximum limit, reverse, while the no go snap gauge, it is corresponds to the minimum limit. Now, the difference in size between the go and no go snap gauge, as well as difference in size between the go and no go plug gauge, is the equal to the tolerance of the tested hole or shaft. I have already told that work tolerance, it is just the difference between the no and go and no go gauges. Another point of importance is that the go plug gauge, it must be of corresponding section and preferably full length to check the straightness of the hole. Whether the hole is straight or not, it can only be checked if the go plug gauge, it is of full size, full length. Thus, it not only controls the diameter, it can also check the alignability of the hole. How it cannot check the degree of ovality, how much is the ovalness in that hole, that cannot be checked with the help of the go plug gauge. And the no go plug gauge, it should be short, and its function is dependent on not only on the diameter but also on the circularity of the hole. So, this point is should be clear that the go plug gauge, it should be of full length to check the straightness, and the no go plug gauge, it should be relatively short. Now, wear allowance consideration on gauge maker's tolerance. Now, since the gauge maker, they can't make the absolutely accurate gauges, permissible deviation in accuracy must be assigned for. Furthermore, the measuring surfaces of go gauges, which constantly rub against the surfaces of part to be inspected, they lead to their wear and tear and lose their initial size. Thus, due to wear and tear, the size of the go plug gauge, it gets reduced, while that of the go snap gauge, it is increased. Reverse, it is a reverse of that, because in case of go plug gauge, we are checking the hole, size will get reduced with the wear and tear, and in case of go snap gauge, we are checking the shaft. So, this the size will be increasing with the help of the due to wear and tear. So, for to increase the life of the gauges, we have to consider the wear allowance of the gauges, because otherwise if we don't consider the wear allowance, then the life of the gauges will be getting reduced, and so the cost will naturally be high. For this reason, the new go plug gauges, they are made with 2 positive deviations, and go snap gauges, they are with 2 negative deviations from the nominal size. Now, important points for design, let me tell you, the form of go gauges should exactly coincide with the form of opposite or mating parts, that in the case of standard gauges. Now, the go gauges, they are complex gauges which enable several related dimensions to be checked simultaneously. So, we should definitely consider the wear allowance in it to prevent the wear and tear of the go gauges. Now, in case of inspection gauges, go gauges, they must be always be put into conditions of maximum impassibility. Okay, means the go gauge is designed as that it should allow maximum impassibility, it should not pass through the pieces we are checking, because if it is going to pass, then actually we cannot differ between the inspection gauge and the work gauge. Now, the no go gauges, they are gauges for checking a single element of feature, means in one pass, in one set of dimensions, we can only be checked by one go gauge, and for other set of dimensions we need another no go gauges. In case of inspection no go gauge, it should follow the condition of maximum passability, that it should pass through the objects we are going to check. So, these are 2 opposite ones, go and no go gauges. Now, next comes the gauge maker's tolerance. Now, keeping all above main points for gauge design, there are 3 methods of giving tolerances on gauges, that is on snap and plug gauges. First method, it is the, in this case, in case of workshop and inspection gauges, in this method the workshop and inspection gauges, they are made separately, that is their tolerances zones are very different from each other. This was actually developed in the earlier years of ago. According to this system, the tolerance on the workshop gauges, they are arranged to fall inside the work tolerance, that is which the work tolerance which we have specified, the tolerances on the gauges, workshop gauge, they are below that work tolerance, while the inspection gauge tolerances, they fall outside the work tolerance, means they are at a higher limit of the work tolerance. Now, disadvantages, what are the disadvantages of workshop and inspection gauges? Some of the components which are in work tolerance limits, they may be rejected under workshop gauges, but when they are checked by the inspection gauges, they are accepted. So, this is a contradiction. This is due to the difference in the work tolerances of workshop gauge and inspection gauges. Now, some components which are not in work tolerance, they may be accepted by the workshop gauges. So, this is the contradictory statement. Now, the reason for this is that the workshop and inspection gauges, they are made separately as their tolerances zones are different.